Now we're going to multiply binomials times any polynomial. So remember when I told you how to double distribute? We are just going to double distribute again. And if there was 3 terms, you could triple distribute, or as many times as you need, because this works pretty much for anything. So when I have x plus 5 times x squared plus 2x plus 3, I'm going to take the x from the x plus 5, and it's going to distribute to as many terms as it needs to in the second parentheses. So x times x squared is x cubed. Add the exponents. X times 2x is 2x squared. Again, add your exponents. And x times 3 is 3x. And then I'm going to come back in blue and grab the plus 5, and it's going to distribute to all 3 as well. So 5 times x squared is 5x squared. 5 times 2x is 10x. And 5 times 3 is 15. So that was multiplying. Now I need to combine like terms. It looks like I have 2 terms of x squared, and I also have 2 terms of x. So in red I have x cubed, and then the 2 like terms in purple, 2x squared plus 5x squared adds to 7x squared. And the orange one that I underlined is 3x plus 10x is 13x. And then lastly, I have the 15. Now, one other way I could have organized this is when I distributed x cubed plus 2x squared in red plus 3x. And then when I distribute in blue, when I have 5x squared, instead of putting it to the side, I could have put it right underneath the other x squared term. Then I have plus 10x, and that would go under the other x term, and then plus 15, and that would go over to the side because it doesn't have any like terms. And then when you add, you could just add down. X cubed plus 7x squared plus 13x plus 15. It doesn't really matter to me which way you write it. You're still going to get the same answer. So whatever makes you happy. On the next problem, x plus 3 times x squared minus 3x plus 9. I'm going to first start with the red. I have x, and that's being multiplied by every term in the second parentheses. So x times x squared is x cubed. X times 3x is 3x squared by adding my exponents, and x times 9 is 9x. If I use the vertical method, when I come back and grab the plus 3 and distribute the plus 3, 3 times x squared, that's positive 3x squared, and then I could put it right up under the other x squared term. Next, I have 3 times negative 3x, that's negative 9x, and then 3 times positive 9, that's positive 27. Once I have everything lined up, when I add, I can simply add down. X cubed, negative 3x squared plus 3x squared adds to 0. 9x minus 9x also adds to 0. So those happen to add to 0, and I don't need to write them. So that's an interesting problem. On our last problem here, I have 4x cubed, and that's going to distribute. 4x cubed times 5x cubed, that's going to be 20x to the 6. 4x cubed times 4 is 16x cubed. Now I could either write it to the side when I distribute my next term in negative 8, which I'm going to do here in blue, or you could write it underneath. It doesn't really matter to me, whatever you like. Negative 8 times 5 is negative 40x cubed. Negative 8 times 4 is negative 32. And the like terms I have here are the x cubed terms. When I add those, I get negative 24x cubed. In red, I get the 20x to the 6 comes down, and also the negative 32 comes down. And there's nothing else that's like terms, so this is my final answer. And that concludes our lesson on multiplying polynomials.